Welcome back to the deep dive. If you've ever wondered how, a live camera feed from some remote location just instantly appears on your screen, today we're looking at the piece of tech that basically makes that magic happen. We're doing a deep dive into the Thor Broadcast H-1SDI-DVBS2. It's the essential bridge between the camera lens and the satellite.
And that's really our mission today, to understand the advantage of this three-in-one box. It's a key piece of gear inside what they call a DSNG truck, a digital satellite news gathering truck.
Right.
And it does three huge jobs: encoding, modulating, and what's called ASI multiplexing, all to take that one single channel of beautiful uncompressed HD video and get it ready for space.
Okay, so let's unpack that. The first step, you start with this really clean HD-SDI feed, right, like 1080p. But you can't just blast that raw data up into orbit.
No, absolutely not. That's where the efficiency comes in. The unit takes that HD-SDI input and it converts it into the DVB-S2 standard.
Which is the modern satellite language, basically.
Exactly. DVB-S2 lets you pack way more data into the same amount of bandwidth compared to the old DVB-S standard, which, by the way, it also supports, for legacy systems.
Okay, and that efficiency, that translates directly to saving money for the broadcaster.
A lot of money. Satellite time is not cheap.
Which brings us to the codecs. I see you could choose between H.264 and the older MPEG-2. Why would anyone even choose MPEG-2 today? H.264 is so much better.
That's a great question. And it comes down to flexibility. While H.264 is, what you want for quality and savings, some older satellite receivers out there can only understand MPEG-2.
Ah, so it's a compatibility thing.
It is. But the real control, the real-time decision-making, is in the bit rates. You can adjust the video feed from a tiny 0.5 megabits per second all the way up to 19.5.
And that's the trade-off right there. If it's just some non-urgent footage, you dial it way down to save cash.
Right.
But if it's a critical live event, you crank it all the way up to 19.5 and just eat the cost for max quality.
Precisely. And while that's all happening, you've got your standard audio codecs, too, like AAC.
Yeah.
But it gets even more interesting with the ASI input.
Okay, so follow the signal for me. The main camera's encoded. What if the crew needs to send up other stuff on that same satellite slice?
That is the power of the integrated ASI MUX, or multiplexer. Satellite bandwidth is premium real estate. You want to use every bit you pay for. The ASI input lets you feed in other externally encoded programs, maybe a return feed for the anchor, or different commentary tracks.
You can bundle it all together.
You bundle it all, up to 80 megabits per second of other streams, all into one single DVB-S2 carrier. It turns a one-camera job into a multi-channel hub.
That massively increases what you can do with one piece of gear.
Right.
But I imagine with all that valuable content, security has to be built in.
No, it's paramount. We're not talking about internet security. A satellite signal can be picked up anywhere. So this unit supports BSS encryption, the basic interoperable scrambling system. Without the pre-shared key, that feed is just scrambled nonsense. It's impossible to decode.
And managing all of this, the bit rates, the BSS keys, the muxing, it has to be fast, right?
Yeah.
Especially when you're under pressure in a news truck.
It does. And you can use the front panel, the little keyboard and LCD screen. But the big shift for modern teams is the remote management. The entire unit can be controlled through a standard web browser.
That's a game changer, just reducing the complexity for the people actually on the ground.
Totally.
And speaking of making things easier, there's one last little detail I saw. The power feature.
Yes. The logistical headache solver, power over coax.
Tell me about that.
Through that same management interface, you can tell the unit to send 24 volts of DC power out through the same coax cable that's carrying the signal. It means one less power supply, one less cable to run, and a faster setup for the uplink antenna. It's brilliant.
So when you put it all together, this box is really the definition of flexible engineering for mobile broadcasting, isn't it? It's handling, encoding, multiplexing, modulating. It lets you balance cost against quality on the fly.
It really is. And if we connect this back to how things work today, with smaller field teams and big centralized production hubs, and that ability to manage every single setting, from the codec to the security keys, just from a web browser, that might be the single most valuable feature. It means the broadcast engineer doesn't even need to be in the truck. They can run the whole thing from headquarters. That remote agility enabled by this little box, that's how news moves at the speed of light now.